All right, let's go ahead and go on to Valgrind. We've talked about memory pointers. C++ is not going to tell you if you have a memory leak. It doesn't care. Yeah, it's like that. So there's actually many programs to help with memory. Pretty much the de facto one nowadays is Valgrind. So that's the tool we're going to use. It does some memory debugging. It definitely does memory leak detection, and it will do memory profiling if you wish to. But for this class, we're really going to focus on memory leak detection and not the other two uses, because I think that's better for a different class. The way this works is Valgrind takes your program, puts it inside of its virtual machine, and then runs your commands one at a time inside of it. What that means is Valgrind is going to run significantly slower than if you're just going to run it on your computer. Here's a successful run. I think last time we went ahead and used Valgrind real quick. Great. So we may not need to look too much into this. Okay, yeah, we did. So yeah, we're good. Real quick, just make sure it keeps track of the heap memory used on exit. Notice an exit 0 bytes and 0 blocks. So we're good. We actually didn't use anything here. How much memory was allocated? None. How many memory errors, out of bounds accesses were detected? This is actually a pretty good one. If you're accessing something slightly out of bounds, sometimes, and I will say by sometimes, pretty much all the time, C++ is perfectly okay with that and will never give you an issue. Valgrind will at least tell you, hey, look, you're accessing memory out of bounds. Don't be doing that. Fix it. One last note. When you run it, you're going to come up with a number over here. That's your process ID. For this class, it's completely superfluous. But what's going on is every process or job or program you run is assigned a process ID. And that's just it, showing it over there. That's all. Okay. So let's go ahead and look at the first definitely lost memory. It main. What's the issue with this program? It never deletes. Right. So if I ran it real quick on exit 4K, lost in one block because it was allocated as one block. Definitely lost right here. Definitely lost means we still have a pointer to it. Indirectly means we no longer have a pointer to it, but it's somewhere. Possibly lost means that things got too complicated and Valgrind was not able to determine if the memory was deallocated or not. I'll tell you most of the time possibly lost means you lost it. So fix it. From experience, most of the time that's what it actually means. So a better version, we delete it afterwards. And it says all blocks were freed, no leaks were possible. Are possible, which is great that it can actually guarantee you at some points that you haven't leaked into memory. Notice it told us how much heap memory was used even though we freed it. This is perfectly fine. This is just giving you a report of how much memory you used and how much you freed. That's okay. That's actually fine. That's good. That means you're using your heap correctly. It's when it says definitely lost, whoops, back here, that's when bad things happen. Or in use at exit, that number is greater than 0, you have problems. If you somehow have a number less than 0, I'd be curious what you did. Okay. All right. Off by one error. So let's go ahead and look at that code. Anyone tell me what the error is?
Yeah, it's including the 1024.
Right. And is that within bounds or out of bounds? Out of bounds, right. Okay, so it's an out of bounds error. Valgrind will actually tell you when you run it, invalid write of size 4. So you are trying to write 4 bytes to the wrong location. Why is it 4 bytes? Size of what? Integer, correct. All right. So you're invalid, you're writing 4 bytes to the wrong place. It doesn't really give you much information about it. So what you can actually be useful here, because Valgrind will interface somewhat with GDB's debug flags, and then when you run it, it will then tell you the line that you have your problem. In this case, it was test.c at line 4. Okay. Would it help if I just wrote this up real quick and we just step through it just to show you? Sure, why not? All right. I don't have Valgrind directory. So we'll include stdio.h. And did I make this a separate function? Nope, it's all in main. Great. Huh. Let me go ahead and gvim it for us. If I recall, forgot to increase the font. There. And so I created int star. Did I call it X? We'll just call it ints. Sure. It's an equal to. There we go. Oh, 2, 4. I plus plus. And sub I equals I. And that's probably the whole program. Oh, we deleted afterwards. So, we'll go ahead and do a quick little makefile just to practice. Good old C flags. We'll start off with nothing. All will depend on test.o. And then we'll have it do g++ C flags -o, we'll call it test from test.o. We'll have another role for test.o, which will depend on test.cpp. We'll do g++ with, of course, the C flags. Oh, we need an S up here. -c test.cpp. All right. If I type that all correctly, hit make. Good. We'll run it. Hey, look! It didn't give me an error. We're perfectly fine. Like I said, C++ in general doesn't care. But if I try and Valgrind it, says okay, goes uh-oh, invalid write, and then doesn't really give you too much information. 2ALX, 2 free, so we don't have a memory leak, but we have invalid memory usage. Now, if you have an invalid memory use, you may still pass the test cases, or you may not. That depends. I highly recommend you always fix these, especially for your project, because if you have any memory issues and your project starts doing weird things, this is probably why. Because you're overriding something you shouldn't be, and that's just messing up your data structure. But like I said, we need to add the debug flag. Let's go ahead and add a clean directive so it makes it easy. rm, we got test.o and test. Make clean. Make. Again, I run it. Everything's happy. Valgrind test. Now this time, it'll tell you test.cpp, actually test.cpp line 7. That is not the right one. Okay. Line 7, right there. Could probably put in a breakpoint and watch I change as well. And eventually get to it. But at least Valgrind's telling you which line number it is, which hopefully gives you a good clue as to what's going on. Any questions? All right. I know these two tools may not seem too, well, hopefully they seem useful. They're going to take you some time to get used to, but it's worth the effort. All right, so it's used to detect memory leaks, access errors. Valgrind provides other tools to profile, but that's beyond the scope of this class. Notice that Java has memory debugging built into it, but C++ you have to use a separate program. Why is that? Yes?
It's less costly on the hardware and other things that has to interface with the
Okay, yeah, that's a good way to put it. So by not having debugging built in, you're consuming fewer resources. Now, okay, good point. Now, why is that advantageous for C++?
Run faster.
Sure, it runs faster. And again, remember, C++'s target is in general low-level operating systems or system-level programming where performance and access to memory is vital or very important. Java works on a different end. You're usually doing something with webs on the web space, in which case you don't care about pointers because you don't have a device driver to interact with. You're just trying to serve a user who's logged into a server, or maybe you're running an app on your phone. You just need to serve that app. So you don't really care about being able to directly access a device driver. You just want to be able to run your program as safely as possible. So debugging support built in makes sense. Okay, important question, because the differences between Java and C++ will come up on your midterm and final. Okay, other tools that we're going to get into hopefully shortly. gprof for profiling tells you where your program is spending most of your time. We're unfortunately not going to do that today. It can help, but if you have a profiler, it'll tell you where to spend all your time, because it'll say, hey, look, 90% of your time is spent in this one function. Probably shouldn't investigate that function if you're having some issues. GNU plot, which we will get to, is real good for automatically generating plots for you. So if you have a program and you want to see how efficient it is due to a range of inputs, we can use GNU plot in a specific program. A while ago, I had to teach bash, which is your shell, but that is now covered in 301, and it's not completely required, really necessary for this course that you become a master of it, just that you're able to use it and basically run make. So I'm not going to go over bash next. You will cover that in 301. Has anyone here taken 301 or is in 301? Okay, so about half the class. That's fine. Those that haven't taken, don't worry. It does give you a slight help, but not significant in this course.